Hello, in previous video we showed how you can handle a situation where you want a proper axis position according to mechanical position, and the best way how to do it is to make a proper sizing and selection, in particular your gearbox. Now we have here scaling of our master where we put 3:1 for our gearbox, 360 units in application, and we have also modulo 360. Now in this setup we know that every time our encoder does a rollover, our axis will not do also the rollover exactly at the same position. Maybe you are already on the field, you are in commissioning phase, but you need the functionality and now you don't have any more time or resources to change your mechanics, change the gearbox to do the proper scaling. To fix this problem, there is a dedicated function block and it's called persist position, and we are using single turn version of this function block. This function block also comes with a dedicated data structure which you need to store in certain non-volatile memory area, that after a power cycle the data is restored and the function block sets up the proper axis position that you are again aligned after a power cycle of your machine. Now you see me here putting this data structure in standard global variables, and the proper way how to do it is to put this data inside persistent variables or persistent retain variables. But I am using Raspberry Pi as my PLC, and Raspberry Pi does not really have usable non-volatile memory area. What I've done is create one small piece of program where I'm using a file to store the data into a file, and then on a boot up I'm reading this, and when the function block is enabled it will restore the data after the access is already online. How do we call this instance of our persist position single turn function block? We do it in our motion FBs with all other function blocks, and or axis we use a master. Then you need to add your structure, and now you need to put number of bits. This is maximum size of your multi-turn encoder. So now we know that in one turn there is 131072 points and we have 4096. When we multiply those two numbers we will get 2 on 29. So 29 here is the number for our situation. And also we have dedicated visualization with a button which we use to store data into a file. Now let's log in and simulate this. Let's open a drive. Here you can see the axis position and you can see the drive position. So if we move in positive direction, we are much closer to roll over the encoder. So this is what we will do. Let's enable our master axis. Let's use some higher velocity that we do a roll over quite fast. And we will also prepare MC stop. So when it goes over 538, we know that we made a rollover. So it's already over. We'll stop. And we will disable the drive. We are very close to 360. Let's make a print screen. So what we have the axis position and also what we have the drive position. And now we will do a power cycle of our machine, but before we do it, we need to write our data structure into a file. Let's do a power cycle. Now we will lose a connection. Okay, and by this time the controller is already online, so we log in. And as you can see, our position is restored 356, 356, and if we check our drive position, it's completely different. Okay, that's it for this video. Hope you like it. If you did, please give it a thumbs up. Don't forget to subscribe, and I'll catch you in the next one. Bye.